In this problem, I stored makeup data using dictionaries and tuples, where each product has details like brand, shade, category, expiry, and skin type. First, I cleaned up products by removing expired one and those that don't match the user's skin type. Then I grouped them by category. Using recursion, I generate all possible makeup combinations by picking one product from each category. I also ensure that at least one premium brand is included. I detect duplicate products where the same shade and category appears under different brands. The output shows duplicates as rose, lipstick, and Lori foundation. Then I calculate which woman has the most deserves enable products. That is Asha. Finally, a valid combinations are generated. Asha has one valid combination, but Ria has none because her products don't satisfy the premium brand condition. In this case, I represented dishes and ingredients using tuple inside a dictionary where each item can depend on sub item. Using equation, I explained the dish into all raw ingredients for the given dish. The required ingredients are tomato, onion, and paneer. Then I calculate all total preparation time and cost recursively. The output shows total time as 70 and total cost as 360. I compare required ingredients with available stock using sets. Since all ingredients are available, the missing set is empty. Finally, I calculate dependency depth using recursion, which comes out to be 3, meaning the dish has 3 level of dependency. Here, apps are stored as tuple and user data as a dictionary. I use sets to compare user interest with app tags and filter out apps that are already installed or blocked. Then I calculate similarly between apps based on common tags. Using recursion, I explore indirect recommendations chains. This means if app is similar to Ender, I keep exploring futures connections. The output shows that quiz app is directly recommended and note app is also recommended through a recursive part. So the system provides both direct and indirect recommendations along with their part. In this problem, messages are stored as tuples and organized using a dictionary by date. I use sets to identify activate users and repeat silent users. The output shows that group G is silent because it only receives messages. I couldn't not. I count password frequency using dictionary and the output shows the per word project appears most frequently. Using recursion, I trace the message chain which simply lists all messages in sequence. This helps analyze communication patterns and basics. Spread. Here I store city and food stop data using dictionaries and tuples. I use this recursion to explore all possible routes, starting from a city while ensuring constraints like budget limit, row repeated cities, and no repeated queue line. The output shows two routes, one staying in a city A with zero cost and undergoing from A to B, carrying biryani with a low total cost of 150. Each route tracks the path, food stride, and total cost. This helps in selecting the best route based on food, delivery, and budget. In this case, I stored customers' or customer orders and referral data using dictionaries. I calculate a suspicious score based on return ratio, high value products, and repeated reason codes. The output shows that customer C1 is a high risk because of repeated expensive returns, while C1 is low risk. Using recursion, I trace referral chains between customers. The output shows that both C1 and C2 are connected, forming the largest suspicious cluster. Here, courses are stored as tuples and the student data as dictionary. I use recursion to expand request chains for course C2. The request part includes C1. When I check eligibility by comparing completed courses with request since the students has not completed any course, only C1 is eligible. C2 is characterized as future course that can be taken after completing C1. The output clearly shows eligible and future courses. In this problem, waiver data is stored using dictionaries and tuples, and series relationships are stored separately. I use recursion to explore connected series to sequels or similar links. The output shows that C3 is recommended to CS1. I calculated mode trends using frequency counts, and the output shows that the user repeatedly watches count with a happy mode. I also check genuine trip, which means the user watches only one genuine. Since all watched content is auction, the output shows true. This happens in understanding user behavior and improving recommendations. Thank you.